Hello, this is a synopsis of Chapter 11, which is capital budgeting. Now, what this chapter is dealing with is when a firm makes a decision, a long-term decision to undertake a new project or start producing a new product. So a capital budgeting decision is a decision that is a long-term decision. So they want to be really sure that they're entering into a decision that's going to be profitable for them. So if you think about if a company is wanting to add a new store or have a new line of products or a new product, or say a car company coming up with changing the style of one of their automobile models. These decisions, once they make this decision, it's long term, so they want to be sure that it's going to be profitable. So we have some different ways that we can analyze these capital budgeting decisions to see if they're profitable or not. And so that's what we're going to go through in this chapter. So first of all, this is an overview of what we're going to be looking at. We're going to talk about some of these methods. The most important method that we're going to talk about is the net present value method. Then we're going to talk about the internal rate of return, the modified internal rate of return, and the payback methods. Payback method is the simplest one, but doesn't really give you a whole lot of information. Then, as I said, the NPV is most important. Then we have the IRR and the MIRR. So we're going to be learning basically these 5 methods in this chapter. Okay, so as I mentioned, capital budgeting involves additions to fixed assets, long-term decisions, and it involves large expenditures. So it's important for the firm. So they want to make sure that they do some analysis to try to figure out whether it's going to be profitable or not before they undertake any type of major capital budgeting decision. So there's 2 different types of projects. There's independent projects and there's mutually exclusive projects. An independent project just means they're not dependent on one project stands on its own. So if you have independent projects, it just means you could pick all of those projects. You're not trying to pick one or the other. So if the projects are independent, you would pick all the projects that were profitable. If you have a mutually exclusive project, that means you're analyzing project A versus project B. Then you're going to pick the one, obviously, that's most profitable. All right, so typically we have what we're doing when we're doing these capital budgeting calculations is we are finding the present, we're looking at a cash flow stream and we're finding the present value of the cash flow stream. So when we talk about net present value, we are analyzing the present value of the cash flow stream that this project is going to give us. And so here they're talking about cash flows. A normal cash flow stream is when you have the cost of the project, so your initial cash flow is negative, and then all the other ones are positive. A non-normal, and that's typically what happens. A non-normal cash flow stream is when you have, it's negative, goes positive, and then goes negative again. So you could have this situation if, let's say that you buy this piece of equipment and you have a negative cash flow initially because you bought the equipment, and then you have positive cash flows for 5 years. And then in the 6th year, the equipment is obsolete, but it's going to cost you to get rid of the equipment. So you have a negative cash flow again. That would be an example of a non-normal cash flow stream. So we're going to be taking the net present value. So remember, basically all this is just, it's a sum of your present value of a lump sum formula. So here they're just saying we're going to sum up all the cash flows, divide those by, it's each cash flow for each year divided by 1 plus the interest rate to the nth power. Well, they're saying t, but it should be n. I mean, it can also be n. So this is basically the same formula as the present value of a lump sum. If you said this were the future value, And this is divided by 1 plus the interest rate to the nth power. It's the same thing, but it's just using cash flows. I'm going to show you how to use the cash flow function on your calculator though, which is much easier. And then of course you can do it in Excel also, but for the exam, you want to know how to do it on your calculator. And so we are going to be looking at, if you look at the second row of your calculator here where it says cash flow, NPV, IRR, those are the functions that we're going to be using to calculate the NPV and the IRR. Okay, so we have these two examples, and we're going to be going over this example throughout the slides. This project is costing, let's just keep it simple and say $100. This project is, let's say it's a piece of equipment. It's costing them $100. In year one, it's going to give them cash flows of $10, year two, $60, and year three, $80. And this is just another, project, but we're just going to concentrate on this one. So let's take a look at these different methods, these different capital budgeting methods using these numbers here. Okay, so the first thing we're gonna calculate is the project's net present value. So what they've done here, hang on a second here. Yeah, they're going to show, okay, I just wanted to make sure the cash flow functions were here so I can show you how to do it on the calculator later. But let's do it the long way first. So here is this project, and they have, in year one, the cash flows are negative 100, year two, 10, 60, and 80. So over here, we're just simply taking the present value of the cash flows using the present value of a lump sum formula. So this stays at negative 100, $10 in the first year. We bring that back to the present value. So it's going to be $10 divided by 1.1. And that's given us $9.09. So this weighted average cost of capital, this is what the money's costing them. In other words, they had to borrow this. They either borrowed this from their bondholders, got issued bonds, or they issued stock. But the average, as you learned in the last chapter, the weighted average cost of capital is what the capital is costing the firm. So they have to pay, they have this $10 that they got in a cash flow, in the form of a cash flow, but they have to pay they have to pay the cost of capital of 10%. So they're really only able to keep $9.09. Okay, and then in year two, the cash flow is $60. You have to bring that back to the present value. So it's $60 divided by 1.1 squared, you get $49.59. Last cash flow, $80, excuse me, divided by 1.1 cubed, you get $60.11. You net this all out, and we have a net present value of $18.79. What does this mean? This means that after the company paid off, or after the company paid the 10% to their investors, this project still netted them $18.79. So it added value to the firm. Therefore, you would accept this project. You accept any project that has a positive net present value because it means that they've added value to the firm. It's profitable, in other words. If it were zero, they were breaking even. If it were negative, they're losing money, and so you would not accept the project. So if this project were independent with project S, you would accept both of them. You would accept this project, you would accept any project that has a positive NPV. If this project were mutually exclusive with project S, where you can only accept one, you're going to accept the one with the higher NPV. And so they have run the numbers for project S, and we see that this project has a positive NPV too. This is actually higher. So if they're mutually exclusive, we would be accepting this one. Okay, so just to recap the NPV, you take the present value of the cash flows and you net that out with what it's cost you. And any positive net present value project has added value to the firm and should be accepted. If it's independent, you accept all of them. If they're mutually exclusive, you accept the highest one. And what does it mean? It means that the company has added value, in this case, even after paying the 10% to their investors, it's still profitable. They've added value of $19.98. So we did this the long way, calculating these individual present values of a lump sum, but we can put this in our calculator. So here is the calculator solution. All right, so the first thing you're going to do is hit cash flows, hit the cash flow button, and then you're going to hit second and clear work. And you're going to have, it's going to say CF0 equals 0. That's your initial cash flow. You're going to put in $100, hit the plus minus sign, and then you're going to hit enter and the down arrow. So let's do that. 100, it's negative, hit the plus minus sign, and then I'm going to hit enter up here at the top and the down arrow. And now it should say CO1. That's my first cash flow. Come down here, I'm going to enter $10, enter and the down arrow. So let's do that, 10, enter and the down arrow. Now it's going to say FO1. That's asking me the frequency of this cash flow. How many times did this $10 cash flow occur? Sometimes cash flows occur more than 1 year. You see where it says FO1 equals 1, it's defaulted to 1 cash flow. So you just hit enter and the down arrow. Now we're at cash flow 2, put in $60, enter and the down arrow. It says FO2, hit enter and the down arrow again. Now it's saying CO3, put in $80, enter and the down arrow. And then it's the frequency is 1, just hit enter. You don't have to hit the down arrow because we're not going to cash flow 4. If you do it by mistake, you can actually go through these up and down arrows to go through all your cash flows to make sure that they're correct. But anyway, at this FO1, you just hit enter. Now you're going to hit NPV because that's what we're looking for. And it's going to say I equals 0. Now you put in the cost of capital, which is 10. So put in 10, enter, and the down arrow, and it'll say NPV equals 0. Hit compute right here. And there is our answer. NPV, the net present value is $18.78. Okay, 1 penny less than what we calculated just due to rounding when we were doing it all by hand on the previous slide. So that's how you calculate, that's how you do this on the calculator. Okay, now here's one of the problems with the NPV. Let me go back to this slide. So as I mentioned, NPV, the net present value, is considered to be the strongest capital budgeting method. However, what if I asked you, well, what's the rate of return? What rate of return are you getting on this project? You really couldn't answer that, right? All you can say is, well, I know I made 10% because I was able to pay my investors 10%, and I also made an additional $18.79. So I made 10% plus $18.79, but I can't tell you what the rate is. So the internal rate of return, what the internal rate of return does is it gives us an actual rate of return. What the IRR does is it forces this NPV number to 0 and puts this into the rate of return. So basically, the simplest way to think about it, it's taking this 10% plus adding this $18.79 and figuring out what that rate is. So the IRR forces the NPV to 0 and calculates a rate of return. So let's go back to this IRR. You can't, there's really no formula for the IRR because Well, you have to, in the old days, if you're going to do it using the math, you have to kind of do a trial and error method. So really the only way, it's a guess. So the only way to get the IRR is using your financial calculator, which is super simple. So all you do is you enter in your cash flows, and you don't hit the NPV button, or you don't, because you're not calculating NPV, you don't put in a rate. So you enter in your cash flows, and then you just hit IRR, which we can do now because these cash flows are already in here. So you hit IRR and compute. And after a couple of seconds, it gives you the answer. And the IRR is 18.13%. So that's our internal rate of return. So the methodology for the IRR is, or the decision-making process is, as long as the internal rate of return is above the cost of capital, you would accept the project. So 18.13% is above 10%, so we're accepting the project. So you would accept, if these were mutually exclusive between the two, you would accept S because it's a higher IRR. But if you could accept both of them, if they were independent, if they were independent, you would accept both of them. So they call that weighted average cost of capital is also called the hurdle rate. I think I mentioned that on a previous lecture. So as long as you're above the hurdle rate, you would accept the project if it's independent, because you're making money. Okay, so that's how you calculate the internal rate of return. Now, there's one problem with the internal rate of return, and that is it's assuming that we have this internal rate of return of 18.13%. Well, when it goes through its calculations, it's assuming that these cash flows are being reinvested at the internal rate of return of 18%. So that really gives you probably a higher number than is warranted, because if you think about it, let's go back and look at these cash flows. So what the IRR is assuming is that these cash flows that the company's getting, they're reinvesting this money and they're getting the 18.13%. But that isn't really realistic, because the going market rate is the weighted average cost of capital is 10%. So, companies do reinvest, they invest their cash flows, but it's not realistic to think, oh, they can reinvest these cash flows at whatever the project IRR is. No, it's more realistic to think if they're going to be reinvesting these cash flows, they're going to get the going rate of return, which is 10%. So, and just think of an extreme example. What if this was a really risky project and had an IRR of 40%? Well, obviously they can't reinvest these cash flows and get 40%. So the bottom line is the internal rate of return tends to overestimate, be a little bit more exuberant, in our estimate of the IRR is kind of high, because it assumes that the cash flows are being reinvested at the project IRR. Therefore, you have what's called the modified internal rate of return. I'll come back to this in a second. So let's go to the MIRR. So this looks confusing, but it's really not. You just have some steps here. So with the modified internal rate of return, we're assuming that the cash flows are going to be reinvested at the cost of capital. So it gives us a more conservative estimate. Okay, so there's two steps to calculating the modified internal rate of return. First, we calculate the net future value of the cash flows. That's right here. Then we solve for I-Y back in the third row of your financial calculator, and that rate is the modified internal rate of return. All right, so if you notice, we have an NPV button on the calculator, but we do not have an NFV, net future value button. So we have to do that the old-fashioned way. So what we're doing here is we're calculating the future value of these lump sums to get the net future value. So that's step one. So in the first year, we received a $10 cash flow, And we were able to invest that at 10% for 2 years. 1, 2. So remember your future value formula is the present value times 1 plus the interest rate to the nth power. So we're going to take $10 times 1.1 squared. This is a little deceiving here because they're not telling you what to multiply it by, but it's $10 times 1.1 squared. We get $12.10. Year 2, we have the $60 we were able to invest for 1 year. So it's $60 times 1.1. This $80, we get it at the end of the project. There's no time to invest it. Therefore, so when you add these up, we end up with a net future value of $158.10. Okay, now for our second step. This is actually quite simple. You just pull this down. This is our present value. In other words, we invested $100, okay? At the end of this whole project, we had $158.10. What's our rate of return? You just calculate you just solve for the I-Y, just like you were doing in chapter 5, and that's your modified internal rate of return. So in your financial calculator, I mean, you can try to do this algebraically, but just use your financial calculator. You're going to put in $100, hit the plus minus sign, so it's negative. That's your present value. 158.10 is the future value. 0 for payment. There are no payments. We just had to use those to get to this, but there's no payments. So 0 payment. 3 is N, and compute I-Y, and you end up with your modified internal rate of return. Okay, so let me tell you that again. 100 plus minus sign, present value. 158.10, future value. 3 and N, 0 payment. Then you hit the compute button and I-Y in the third row, and you get 16.5%. That is your modified internal rate of return. It's above the hurdle rate, so you would accept it. All right, and this is just showing you how to do it in Excel. So that's the modified internal rate of return. Okay, now if you go back to these other slides, they're talking about the IRR versus the net present value. And so they go into, they get into this whole problem, this whole issue where sometimes you can have a situation where you have a conflict between the internal rate of return and the net present value. In other words, the internal rate of return will tell you to pick one project, but if you're trying to decide between two mutually exclusive projects, the IRR will tell you to pick one, but then when you calculate the NPV is higher for the other one. And so there's two reasons that this can happen. If you have two projects and one is, if one project is a very small project with really small cash flows, and then the other project is a large project, like 3 or 4 times higher, the difference in size can cause this conflict. Another reason for a conflict is if you have one project that has the majority of their cash flows at the beginning of the project and the other project, the majority at the end, then you can have a conflict. So if you have a conflict, you always default back to the net present value. That's the better method. So that's basically what they're saying for in this section. Okay, so what have we done so far? We've gone over the NPV, which is really the best estimate. We went over the internal rate of return, and then we went over the modified internal rate of return. So in my opinion, well, I mean, the textbook says NPV is the best one. My second one would be the MIRR. Then the third, I guess, would be the IRR. And then finally, we have the payback method, which just simply tells you how long does it take you to get your money back. It's a real simple estimate. So let's calculate this payback method. This is really the least of, I mean, I would calculate this, but I wouldn't, would not invest in a project just based on the payback method, because there's some flaws with it. But it's kind of nice to see when you're going to recoup your investment. Okay, so this is the payback method. So all we're doing is seeing how long it takes us to recoup our $100. So we have this timeline here with the cash flows for this project L, 100, 10, 60, and 80. We have another row here. These are our cumulative cash flows. We're trying to see when we go positive. So in the first, right now we're down $100. After the first year, we're going to be down $90 because we brought in $10. Second year, we bring in 60, so we're down $30. And the third year, we bring in 80, so now we're positive $50. So when did we recoup our investment? Sometime between year 2 and year 3. All right, so to get the fraction of the year, we're going to take the $30 that came in and divide that by 80. So it's 2 years plus 30 divided by 80. So we recouped our investment in 2.375 years. So there's no, so that, I mean, it is what it is. That just tells us when we've recouped our investment. Now, if we were going to try to pick one or the other, if they're mutually exclusive, just going by the payback method, we should pick Project S because you recoup your investment in 1.6 years. But here's the problem. One of the problems with the payback method, it ignores the cash flows after the payback, after you recoup your investment. So let's say hypothetically, what if both of these projects went out 4 years or 5 years? And let's say 5 years. And let's say in year 4 and year 5, the cash flow for this project was $100 in year 4 and $100 in year 5. The cash flow for this project was $10 in year 4 and $10 in year 5. Well, if you knew that information, you would have a completely different conclusion. If you knew that, then Project L would obviously be the better one because you're getting higher cash flows. But because those occur after the payback, you don't even consider them. So one of the problems with the payback method is that it ignores the cash flows after you recoup your investment. The other problem with the simple payback method is that what's missing up here? There's no cost of capital. They don't even factor in that this money costs you something. It didn't fall from the trees. You have to pay your investors. So it ignores the cost of capital. So that problem can bring us back. That problem brings us to our last method, which is called, we can solve that problem by calculating what's called the discounted payback, where we include the cost of capital. So let's do that next. So here's our cash flows. Here we're calculating the present value of the cash flows. Okay, this is the same thing that we did when we did the net present value the long way. We just calculated the present value of each cash flow. So we have the present value. This, of course, stays 100. So here we're taking $10 divided by 1.1. Present value is 9.09. Okay, here we're taking $60 divided by 1.1 squared. This is $80 divided by 1.1 cubed. And then we do what we did in the last slide. We're finding the cumulative cash flows to see when we go positive. So we have negative $100. We brought in $9.09 after we paid our investors. Then we bring in $49.59. Here so you're taking 100 minus 9, negative 100 plus 909 equals 90.91, plus 49.59 equals negative 41.32, plus $60 equals $18.79. So here we know we've gone positive in year 3. So we're simply going to take we've gone positive rather between year 2 and year 3. So it's 2 years plus 41.32 divided by $60.11, and it's 2.7 years. So obviously, well, since we had to pay our investors here, our payback method the payback's going to be longer than before. It was 2.38 years here. When we had to pay our investors, it went up to 2.7. All right. Okay, so that's I think that's basically it. Here's the last thing. You can have multiple internal rate of returns, multiple IRRs. If your cash flows are non-normal and they go from negative to positive and then negative again, you can have these multiple IRRs. So in that case, you should just go back to the net present value. If you're in a situation where you have non-normal cash flows and you have these multiple IRRs. Okay, so just to recap, for this chapter, make sure that you understand how to calculate the net present value, internal rate of return, the modified internal rate of return, and then the two payback methods. And understand that, why you can have a conflict between between the NPV and the IRR. And if you have a conflict, you should fall back on the NPV. Okay, that's it for this chapter. And have a great day, and I will see you later. For the last chapter synopsis is going to be chapter 15, and that'll be our last one for this course. Take care.